We think we know the story of fire and ice. One burns, the other freezes. An unstoppable force meeting an immovable object. But what if I told you that in their real-life, unseen battle, neither one wins the way you'd expect? And I'm not talking about fantasy novels here. The real clash is a molecular showdown that reveals a surprising truth about how our universe works. This isn't about destruction, it's about the fundamental rules that run the whole show. Fire and ice. They're two of the most primal forces on our planet. We feel their power all the time, from the warmth of a campfire to the sharp chill of a winter morning. In our stories, they're eternal enemies, locked in an epic war. But the real battle, the one that actually matters, happens on a scale so tiny it's almost impossible to imagine. This is a story about a dance between molecules, a clash of atoms and energy that plays by a very strict set of rules, the laws of thermodynamics. Let's start with ice. It seems simple, right? It's just frozen water. But on a molecular level, it's a tiny work of art. Water molecules, H2O, are like little magnets. As they get colder and slow down, they lock into place, forming a beautiful six-sided pattern called a crystal lattice. This rigid, open structure is actually what makes ice less dense than liquid water, a rare trick that lets it float. Now, what about fire? Fire isn't a thing like ice is. It's a process. It's a super fast, energetic chemical reaction called combustion. When you heat up a fuel source, like wood, its molecules start to break apart. Those fragments then react violently with oxygen in the air, unleashing a huge amount of energy as heat and light. So fire isn't an object, it's a chaotic, explosive transformation. So you've got the orderly, crystalline structure of ice on one side, and the chaotic, energy-releasing process of fire on the other. When they finally meet, it's not just a simple matter of one wiping the other out. When you throw ice on a fire, it looks like a simple fight, but it's really a negotiation, and the laws of thermodynamics are the mediators. The first law of thermodynamics tells us that energy can't be created or destroyed, only moved around. That intense heat from the fire is just a massive blast of energy from rapidly vibrating molecules. When this energy hits the ice, it doesn't just disappear. The water molecules in the ice crystal absorb it. This sudden flood of energy makes the ice molecules vibrate so hard that they break free from their crystal structure, melting into liquid water. If the fire is hot enough, the water molecules keep absorbing energy, moving faster and faster until they boil away as steam. So the fire isn't destroying the ice, it's just lending its energy to change the ice from a solid to a liquid, and then to a gas. In return, the water puts out the fire by soaking up so much heat that the fuel can no longer react with oxygen. It's a battle of energy transfer, and the winner is simply whoever has more to give. This is where things get really weird. In certain situations, like when lava meets a glacier, the lava can actually flow right over the top of the ice, gliding on a cushion of steam that forms between them. But the most mind-bending part of this elemental clash isn't what happens when they meet, but how they behave at their most extreme. Scientists have found that superhot plasmas, a state of matter so hot it's often linked to fire and the sun, can behave in ways that are bizarrely similar to ultracold gases, which are chilled to just above absolute zero. Under the right conditions, both of these polar opposites can flow with almost zero friction, acting like nearly perfect fluids. It's a wild parallel that blurs the line between hot and cold, hinting at some deeper, unifying principle in the universe. And if you think that's just a scientific curiosity, nature has already created something where fire and ice literally exist together. It's called methane clathrate, but it has a much cooler nickname, fire ice. Found deep under the ocean and in permafrost, it's a substance where methane gas molecules are trapped inside a cage of frozen water. If you bring a chunk to the surface, it looks and feels like ice, but as it warms up, it releases flammable methane. You can literally set a piece of ice on fire. This molecular battle shows that fire and ice are more than just opposites. They're two sides of the same coin, both governed by the universal laws of energy and matter. So what do you find more awesome, the chaotic power of fire or the structured beauty of ice? Let me know what you think down in the comments. And if you enjoyed figuring out the secret rules of the universe with me, make sure to like and subscribe for more. From the quiet dance of water molecules freezing into a crystal to the explosive release of energy in a flame, the conflict between fire and ice is way more intricate and amazing than we usually think. It's not really about destruction. It's about transformation, about the trading of energy, and about finding surprising connections in the most unlikely of places. These forces remind us that even in a universe of opposites, there are hidden rules and strange symmetries that connect everything, from a simple campfire to the heart of a star.